All right, thank you so much for joining us today. In this video, we are going to talk about tangent line to a curve and normal line to a curve. Then we have some example that we are going to do. I'll give you a trial question. So let me start by saying that I have a curve. Let me call this curve f of x. And then I have a line which touches the curve at one point. And this line, we know that this one, we are going to call it the tangent line, right? So this is the tangent line. Now let's assume that this is a point here. Let's say P1, X1, Y1. Then we are talking about tangent line. And whenever we are talking about tangent line, we are talking about the equation of the tangent line. So the equation of the tangent line is given by Now remember, we talked about equation of the tangent when we were talking about circles. So don't get yourself confused. So this is going to give us y minus y1 is equal to f prime of x minus x1. So the f prime can be the same as dy over dx. So all we need to do is we need to differentiate the function here, and then we just plug it in. So the point will be given. So if the point is given, then what we need to do is that one will give us the y1 and the next one. We differentiate the function, we plug it in, then we get the equation of the tangent line. We are going to take example and we are going to see how we are going to go through that. Now, if we are talking about normal line, if we assume that this is the curve, and then we saw that the tangent line is this, which is blue, right? Now we have another line which is here. So this is the tangent line. This here is the tangent line. And the red is the normal line. So the red is the normal line. Good. So if I have a point here, right? So let me call this point x1, y1. Now what happens here? We can see that this tangent line and normal line here is perpendicular to each other, or let me say the curve that I have here is having a perpendicular distance here. So it means that the slope of the curve, which is f of x, we are going to take a negative reciprocal of that. So equation of the normal line is y minus y1, which is equal to 1 minus 1 divided by f prime of x, then x minus x1. So you see that they are almost the same. The only thing here is the slope which is changing. So when I have the slope for this one to be f prime of x to be, let's say, minus 2, then the slope for this one is going to be 1 over 2. So basically that's what we're just looking at. And when we go back to circle, we see that if we are under circle, then this becomes the equation of the tangent line, and this becomes the equation of the normal line. So pay attention to the difference. Good. So now let's take some example and then we see how we can do it. So since we've talked about implicit differentiation, we are going to also use the implicit differentiation idea here. So let's start by, finding the slope of this function at the point 0, 0. So since we are dealing with the slope, we want to find the slope and see. So given x plus y is equal to x squared plus y squared all squared. Now this is implicit differentiation, or we are going to apply the implicit differentiation. So we are going to differentiate this side and differentiate this side. So the idea is that differentiate the left with respect to x, and then differentiate the right with respect to x squared. So what are we going to get? When I differentiate x with respect to x, I'll get 1 plus when I differentiate y with respect to x, I'm going to have dy over dx, which is equal to, I want to differentiate this. Now we talked about change rule, right? So change rule of the power rule, we need to make sure we take care of the power first. So this is like power. So I'm going to have 2 down, x squared plus y squared, then 2 minus 1. times, then I would differentiate what is inside the bracket, which is going to give me this. So it means that here I'm going to have something like this: 1 plus dy over dx, which is equal to, this is going to be giving us 2x squared plus y squared times, now I need to differentiate this. So when I differentiate 2x, I get when I differentiate x squared, I get 2x, and when I differentiate y squared, I'm going to have 2y dy over dx. Is that right? So that's what I'm going to get. Now, one thing that you need to see from here is, as soon as we are done with the differentiation, it's good to simplify by making dy over the x the subject. But since they've given us the point, we can just plug it in straight, and then we just take it from there, right? So from the point, x is equal to 0 and y is equal to 0. So let's do that. This is going to be 1 plus dy over dx, which is equal to 2 times 0 squared plus 0 squared times, this one is going to be 2 times 0 plus 2 times 0 dy over dx. dy over dx. And guess what is going to happen from here? Since this is 0, when I multiply the, I get 0, it will multiply everything here, so everything will go to 0. So I'm going to have 1 plus dy over dx to be equal to 0. So the slope from here at the point 0, 0 is basically equal to -1. So that is basically how we need to do that. But assuming that the point was not given, then here we need to simplify by making dy over dx the subject. So that's the first one. Let's look at the second one here. So second one here, they've given us sine xy, which is equal to sine x plus sine y. So same thing, differentiate this with respect to x, differentiate this with respect to x, because we are finding the slope, and we know that the slope that they are talking here is dy over dx. So that is the slope. So let's go through the process. When I differentiate sine, we know that we are going to get cos, right? So when I differentiate this, or I can put the differentiation on it before I'll start doing the differentiation. So differentiate this one to sine x plus sine y. So let's go through the process. When I differentiate sine, I get cos, right? So I have like this one in parentheses. So as soon as I'm done differentiating sine, I need to differentiate what is inside the parentheses. So I should have put in this one into parentheses, like xy, in parentheses, so that you understand what I'm trying to say here. So xy in parentheses. So when I'm done differentiating the sine of xy, I need to differentiate what is inside the parentheses, because this is like change rule. And this is equal to, now I need to differentiate sine x with respect to x, and I'm going to just get cos x plus, now I need to differentiate sine y with respect to x. When I differentiate sine, I get cos y. But when I'm done, I need to differentiate y. So let me put this one into parentheses again. So let me just be putting everything into parentheses so that I'll show you what I'm trying to say here. So here with the cos s, when I differentiate this, I get cos s. Then I'll multiply it by what is inside the derivative when I differentiate it, what is inside the parentheses. But when I differentiate x, I get 1. So I'm going to have times 1, so that you understand what I'm doing. Then when I'm differentiating this, I'll get this. But when I differentiate what's inside the parentheses here, I'm going to have dy over dx. I mean, you differentiate y and you get dy over dx. So that's what you're going to get. Let's try and simplify this. Cos xy times, now I need to differentiate this and I need to use the product rule. So I'm going to have, when I maintain x and differentiate y, I'm going to have dy over dx plus, now maintain y and differentiate x, I'm going to have 1. And this is going to give me cos s plus cos y dy over dx. So fortunate for us, we have the point, which is x is equal to 0 and y is equal to 0. So we can just do direct substitution before we go to the rest of the process. So cos 0 times 0 times 0 times dy over dx, then plus 0 times 1 is equal to cos 0 plus cos 0 dy over dx. So cos 0 is 1, but this is going to give us 0. This is going to give us 0. Everything here goes to 0. So you are having 0 is equal to cos 0 is 1. Another cos 0 here is 1 dy over dx. So this is going to give us 0 is equal to 1 plus dy over dx. And this implies that dy over dx is equal to minus 1. So this is implicit differentiation, and you should be able to take your time and do it. Now let's talk about what we just discussed here. Now find the equation of the tangent line and normal line at the point this on the curve. So this is what I do anytime I'm dealing with finding the equation of the tangent and normal line and a point is given. I decide to write the equation down first. So that's what I do. So the equation of the tangent line, at the point 1 and 2. Remember this one here is x1 and this y here is y1. So this is going to give us y minus y1, which is equal to the slope. So dy over the x and then x minus x1. So this is the formula for finding the equation of the tangent. Now at this point, we are going to have the equation to be y minus 2 is equal to dy over dx, then x minus 1. So you see that anytime we are dealing with finding the equation of the tangent and we need to use the implicit differentiation, it's kind of very simple. I just plug in the point inside this. So the only hard work that we are going to do here is how to figure out the dy over dx. That's the only hard work that we are going to do here. Is that right? So let's do that by finding dy over dx here. So we see that y is equal to x squared plus 4x minus 3. So what is dy over dx? Dy over dx will be equal to, when I differentiate this, I get 2x plus 4, right? Now the point given to us, which is this, the point given to us, which is 1 and 2, anytime we are using it here, anytime we are using it in the equation, this and this is x1, y1. But anytime we are using this in the dy over dx, that's the slope. Now this becomes x and this becomes y. So pay attention to that. So since we don't have y, this is going to give us 2 times 1 plus 4, and this is 2 plus 4 and 6. So we just need to plug in this here, and then we are done. So basically that is the idea of, when you are finding this kind of solution here. So this is going to give us 6x minus 1, and if you want to simplify, this is going to give us 2 is equal to 6x minus 6 plus 2, and this is going to give us y is equal to 6s minus 4. So that is the equation of the tangent line. Then the equation of the normal line becomes bonus, because now all I need to do is I'm going to have the same thing, equation of the normal line, right? Normal line at the point 1 and 2 is y minus y1, which is equal to, now here we are going to find negative reciprocal of the slope, which is dy over dx, and then x minus x1. So plug in 1 and 2, and we are going to have y minus y. y1 is 2, but we found out that the slope is equal to 6, so we put it inside there. So minus 1 divided by 6, and x minus 1. So it's the same thing. This is the same thing as this, and this is also the same thing as this. The only thing that's changing is the slope, which is just finding the negative reciprocal of that. So this is going to give us 6y minus 12 is equal to minus x minus 1. And 6y minus 12 is equal to minus x plus 1. 6y is equal to x minus x plus 1 plus 12. So 6y is equal to minus 6 plus 13. So this is the equation of the normal line. So this is kind of very simple. Anytime you know how to find your slope, how to find the dy over dx, the rest becomes very simple for you to go through, right? So it's kind of very simple. Let's go through the same thing here again. So here we are saying that s is equal to e, and remember, as we said, the equation of the tangent line the equation of the tangent line, is given as this. So the equation of the tangent line is y minus y1 is equal to, so it depends on what is given. So this is f, so I'm going to use f prime instead of dy over dx, so x minus x1. So it means that we need y1, x1. And the point given to us, remember, this is going to give us like x1, y1, but they've given us only x, so we need to get y. And remember, this f of x here is the same as y. So I can write this one as y is equal to x over e, then the natural log of e over x. So for me to get y, then I need to plug in this inside this. So let's do that. When I plug in e, I'm going to have e divided by e, ln of e divided by e, right? And guess what is going to happen here? I'm going to have this e over e is 1, another e over e is 1. But ln of 1 is 0, so this is going to give me 0. So it means that the point that I'm going to have is e and 0. This is x and this is y. But anytime we are using it in the equation, this becomes x1 and this becomes y1. So let's do that. This is going to give us y minus 0 is equal to f prime of x, then x minus e. So what we just need to find out is we need to find out the y prime, and then we are done. I said y prime, f prime, and we are done. Good. So let's figure out f prime. Now I'm using f prime. This here is product rule, right? Because I have this function here, I have this function here. So product rule, what I'm going to do is I'm going to let me bring the differentiation here. I'm going to let a to be equal to x over e and b to be equal to the natural log of e over x. So let's go through the process. So what is a prime? When I differentiate x, I'll get 1, so I'm going to have 1 over e, right? Because basically 1 over e out, and it will be left with differentiating x. When I differentiate x, I get 1, so I get that. Then when I differentiate a ln function, we said for us to differentiate a ln function, it's 1 divided by what is inside the parentheses, or times the derivative of what is inside the parentheses. So we see that what is inside the parentheses is the same as e to the power minus 1, x to the power 1, right? Because the x is dividing. And 1 divided by e over x is the same as x over e times. Now when I differentiate this, I'm going to have e times, when I differentiate x to the power minus 1, I'm going to have minus 1 x to the power minus 2. So when I simplify that, I'm going to have this will cancel this. So I'm going to have x times minus, and then the x to the power minus 2 can be written as 1 over x squared, right? The 1 of the x will cancel, so I'm going to have minus 1 over x. So this is what I'm going to get at the end. So it means that my derivative here is going to give me a times b prime and then b times a prime. So let's go through. A times b prime minus 1 over x plus b times a prime. So I'm going to have this natural log of e divided by x. Good. So this is the derivative that we are having, right? And as I said, anytime we have the derivative, we need to go and pick the point since the point is given. So the point e and 0 here, we are going to make this one x and this one y. So this is going to give us f prime of x to be equal to, we don't have y, so we just need to put in the x, e divided by e minus 1 divided by e plus 1 divided by e, and then the natural log of e divided by e. So this is going to give us 1 times minus 1 over e plus 1 over e. Ln of 1 is 0. So we are going to have minus 1 divided by e plus 1 over e times 0, and this is going to give us minus 1 over e. So the slope is minus 1 over e. So that it means that the equation of the tangent is going to be minus 1 over e times that. That's all. So if I want to just simplify, then this is going to be minus x over e plus 1. So this is the equation of the tangent line, right? So for us to get the equation of the normal line, it's kind of very simple. So equation of the normal line is just picking this one, but we are going to change the slope. Or let me say when you pick this one, so this is the normal line, equation of the normal line. But what we are going to do is now y will be equal to 1 divided by minus 1 divided by the slope times x minus e. Same thing. So what will be this? This is, we know that slope is this. So I'm going to have minus 1 divided by minus 1 over e, then x minus e. So this is the same as e x minus e, and this is going to give me xe or ex minus e squared. So this is the equation of the normal line. Very simple from there. Now let's take more example. Now find the slope of the tangent line. So let's find the slope from this one. So the slope means that we need to find f prime of x. So let's do that. This is going to give us 2x plus 5. At the point 2 and 1, so this one f prime of 2, because s is 2, is going to give us 2 times, so this is 4 plus 5, which is equal to 9. So this is very simple. Let's look at b. Write the equation of the tangent at this point. So what the equation of the tangent, this is y minus y1, which is equal to f prime of x minus x1. So this is x1, this becomes y1. So y minus 1 is equal to f prime. X is 2, so I'm going to have f of 2, then x minus 2. Good. I mean, this one should be x1, good, because we need to evaluate it by putting in the x1. So now we saw that f prime of 2 was equal to 9. So of course we are going to have y is equal to 9 times x minus 2, then plus 1. So y will be equal to 9x minus 18 plus 1. And finally we are going to have y is equal to 9x minus 17. So this is kind of very simple. It's just, the idea of how to do the differentiation, right? So that's basically what we just need to do from here. Now we want to find the equation of the tangent at this point again, but this, now we are going to deal with the implicit differentiation, because we can see that we've combined x and y together. So we know how to do this. The equation of the tangent line is y minus y1, which is equal to dy over dx, and then x minus x1. But the point given to us, which is this x1, and this, which is y1, will give us y minus 2 is equal to dy over dx, x minus 1. So the only hard work here is how to figure out dy over dx. So now let's use this equation to check it out. So we are given x squared plus 2xy minus y squared plus 2x is equal to 3. Now we need to differentiate. So I'll differentiate both sides with respect to x. So now let's go through the process. Now when I differentiate x squared with respect to x, what am I going to get? 2x plus. And when I'm differentiating this, I'm going to use the product rule because we have two of them. So I maintain x and differentiate y. I'm having dy over dx plus. Now I maintain y and differentiate x. I'm getting something like this. Then minus, I want to differentiate y squared. When I differentiate y squared like x squared, I get 2y. But since this one is going with respect to x, then I need to multiply this one by dy over the x. So the idea is like I have y squared. So change rule, use the power rule first, 2y. Then when you finish, differentiate what is inside the bracket. And you have something like this. So this is what we have here. When I differentiate 2x, I get 2. And when I differentiate constant, I get 0. Right? So as I said, anytime they give you a point, you don't need to make dy and dy over the x the subject before you plug in the point. You can plug in the point straight so that the simplification becomes very simple. So 1 and 2 in the slope means that x is equal to 1 and y is equal to 2. So I'm going to have 2 times 1 plus 2 times x is 1, so 1 times dy over the x plus y is 2 times 1 minus 2 times 2 dy over the x, which is equal to minus 2. So I just move the 2 here to the other side. So I'm going to have 2 plus 2 here will be dy over the x plus 2 minus 4 dy over the x, which is equal to minus 2. So I'm going to have something like this. I'll just move this 2 again to the right, then multiply through by 2. So I'm going to have 2 dy over the x plus 4 minus 4 dy over the x. When I move the 2, I'm going to have minus 2 minus 2. Now I have 2, I have minus 2. So this is going to give us minus 2 dy over the x. And then I'll move the 4 to the other side. So this one is going to give us minus 4. And when I move the 4, I get another minus 4. So I'm going to have minus 2 dy over the x, which is equal to minus 8. And then I'll divide this one by minus 2, divide this one by minus 2. And dy over the x will be equal to 4. So this is the slope. So that was the hard one that we needed to find. So now the slope is 4. So we are going to have 4x minus 1. And this implies that y is equal to 4x minus 4 plus 2. And we are going to have it to be y is equal to 4x minus 2 as the equation of the tangent line. So here, how to get the slope is basically what is very important for you to go through. Because if you're able to figure out the slope by doing the differentiation, then I think it's kind of very simple for you. Let's take another one. I think from this one, we have another last question before I give you the trial solution. So I try to solve more examples for you to see how we can. I want to find the slope, right? So we think of dy over the x. So now let's go through the process. X plus y to the power 3, 2 divided by 3 is equal to y. So what we need to do is we need to differentiate both sides with respect to x. With respect to x. So this is the change rule. So first I'll differentiate the top. So 2 drops down, 2 over 3 drops down plus this, then 2 over 3 minus 1 times, then I differentiate what is inside the parentheses, which is x plus y. So that is what I'm going to get from here. And when I differentiate y on the right side here, I'm going to have dy over the x. So now let me differentiate what is inside the bracket, and I'm going to have 2 over 3x plus y. And what is 2 divided by 3 minus 1? That's going to be minus 1 over 3 times. And when I differentiate x, I have 1. And when I differentiate y, I have dy over the x, which is going to give us dy over the x. They've given us a point, which is 4, 4. So 0.44 means that x is equal to 4 and y is equal to 4. So let's do the substitution straight, and then we just go. So 2 divided by 3, 4 plus 4 minus 1 divided by 3 times 1 plus dy over the x, which is equal to dy over the x. Good. So let me just continue this from this side. So 4 plus 4 is going to give us 8 to the power minus 1 over 3. right? I'm going to have 1 plus dy over dx, which is equal to dy over dx. Now, what is 8 to the power minus 1 over 3? Now, this one can be written as 8 can be written as 2 to the power 3, right? Times this 1 over this. So the 3 will cancel the 3. So this is going to be left with 2 to the power minus 1. And 2 to the power minus 1 is also the same as 1 over 2. So it means that this guy here is going to give us 2 over 3 times 1 over 2 and 1 plus dy over dx, which is equal to dy over dx. Good. So that's how the simplification is going to be. And then from there, I can cancel the 2. So I'm going to have 1 divided by 3, 1 plus dy over dx, which is equal to dy over dx. Multiply through by 1 over 3. So 1 over 3 plus 1 over 3 dy over dx, which is equal to dy over dx. So 1 over 3 is equal to dy over dx minus 1 over 3 dy over dx. So 1 minus 1 over 3 is going to give us 2 over 3 dy over dx. And then I'm going to multiply through by 3. So when I do that, I'm going to have 1 is equal to 2 dy over dx. And dy over dx will be equal to 1 divided by 2. So that is the slope. So as I said, if we're able to figure out the slope, then the next question becomes bonus. So right now we want to find the equation of the tangent. So we know that the equation of the tangent is y minus y1, which is equal to dy over the x minus x1. So we've done the hard work by finding the dy over the x1, y1. So I'm going to have y minus 4 is equal to 1 over 2 x minus 4. So finding the slope, it's basically what you need to pay attention to. If we're able to figure that one out, then you are good to go. So this implies that y is equal to 1 over 2x plus 2. So this is the equation of the tangent line. This is the equation of the tangent line. Good. And let's take the last question, and then I'll give you a trial question to solve. So same thing, saying that find a point on the ellipse, this given that so this that's have a tangent line which is parallel to this. Okay, fine. So we are having this tangent line which is parallel to this, right? Now when you're talking about tangent line and they are parallel, we know that two things, let me say two lines or two curves are parallel to each other when they have the same slope. So what we are going to do is we are going to find the slope for this and slope for this, and then we are done. So let me find the slope for y is equal to x first. So dy over dx is equal to 1. This implies that dy, so that's all. So that is the slope for the first one. So the hard work comes in when we are dealing with this. So let's try and find the slope for that one too. X squared minus xy plus y squared is equal to 3. Differentiate x squared and get 2x minus use the product rule. So I maintain x and differentiate y plus I maintain y and differentiate x. Differentiate y squared and get 2y dy over dx. And when I differentiate the 3, I get 0. So from this, we saw that dy over dx is 1. And since they are parallel to each other, it means that the dy over dx is also the same as 1 here. So I can plug it in. So I'm going to have something like 2x minus x times 1 plus y plus 2y times 1 is equal to 0. And I'm going to have 2x minus x plus y plus 2y is equal to 0. So 2x minus x minus y plus 2y is equal to 0. So this one will be x plus y is equal to 0. and get something like y is equal to minus x. So this will be the final solution from here. Find a point on the ellipse. So we are going to get something like this. So since even the question is saying that find a point, what you can do it, since now we've gotten y to be equal to this, we can plug it inside this and then we figure out x. Yeah, something like that. Let's try something like that and see. So y is equal to minus x from there. So this will going to be y squared, then minus x times minus x, and then plus y squared again is equal to 3. I think this one's supposed to be x squared, so this will be minus x squared. So this is going to give us this one should be x squared, and this one rather should be minus x squared. Good. It's equal to 3. So let's do that. This is going to give us x squared minus, no, plus x squared plus x squared is equal to 3. So this is going to give us 3x squared is equal to 3. And x squared will be equal to 1. And x will be equal to plus or minus 1. So when x is equal to 1, y will be minus 1 from this, right? And then when x is equal to minus 1, y will be equal to 1. So it means that the point will be 1 and minus 1 and minus 1 and 1. So this will be the point that we need to find. Good. So I'll give you a trial question to do. Solve this and leave your final results in the comment section. So in the next video, we are going to talk about related rate before we can start the idea of critical point, absolute maximum, local maximum, and the rest. So see you in the next video.